Hey everybody, welcome back to CENG 15. We're going to pick up more or less where we left off last time. Just two quick updates. One, we tried to do the sort of combined Zoom and Twitch stream with Breege earlier this morning. It didn't work very well. I'm not knowledgeable enough about interfacing OBS and Zoom together. So Breege and I are just going to record an introduction for her tomorrow, and I'll get that posted to Canvas so that you can meet your TA for the class. And then the second thing is that the lab time tomorrow, remember that basically works like an office hours. So you can just show up with questions if you have them, or just hang out and work. But we don't introduce new material. I don't have any like lecture plans or anything like that. I'll pretty much just be hanging out in that Zoom room that's listed on Canvas. So you can pop in there if you want to say hi or ask some questions on homework. Our task for today, we're going to start our second sort of tiny project. So remember, I said that it's easier to learn about the ins and outs of a language when you have something you're trying to accomplish. You don't just sit down and try to learn everything there is about that language. So we're going to introduce a couple of things about variables and referring to those variables today, as well as a really important concept called indexing, which is going to show up a lot more in MATLAB than it needs to in Excel. Excel, you can do a lot without indexing. In fact, most of the time you can do almost everything you need to without indexing. But in MATLAB, that's one of the primary ways that you update information is by indexing. And so we're going to practice that a little bit in Excel, where you can actually see, you know, okay, I should be pulling from this value. Here's what I actually got, and what do we end up with. So let's hop over to Excel. What I've got here is the completed project, so I wanted you to see what we're aiming for. It starts off with that same normal distribution that we started with on Monday's class. We're just going to add some functionality to it. So we're going to end up with a plot that looks like the one that you can see here. And we've added the functionality in the form of being able to change the mean. So this is shifting where that peak in the plot is, right? It's sort of moving left and right. And we've got this interface, which are these spin buttons that you see here. So we can move the mu back and forth. We can make sigma a little bit bigger, so bigger standard deviation, and a little bit smaller, like that. And we've also got this marker that's sitting on there, and we can move the marker up and down on top of our curve. And as we do that, the value of the function at that particular x value gets updated. And so the latter one, the part with the marker and changing the number up here on the top of our plot, those all have to do with indexing. The mu and the sigma have to do with variables. So we're going to start with the mu and the sigma, and then we're going to transition to the markers. If it's at all like this morning, we probably won't be able to get it all the way through. We kind of stopped with figuring out the indexing on the marker, so we'll see how far we get. I will post this on the YouTube recording of this lecture. You'll be able to see the completed one if you want and interact with it. The code for the completed one is over here. I just made all of the text white so that if you want to try it for yourself and figure out how to get the rest of that functionality, you don't have to worry about seeing the answer right to the side. You can always highlight it all and change the text back to black. But either way, we will finish it up on Friday, whatever we don't get to in today's class. So the first thing that we're going to do, I'm going to give myself a new sheet over here, and we'll call this in class. And I'll zoom in a little bit so that you can see it better. And then I'm going to lock the left 4 columns with freeze panes. So I went over to view and then freeze panes, and I had set my cursor to be right here on cell E1. So everything to the left of that will get frozen. And I'm going to add my notes over here and my work over here, so that we've got a couple of different things to do. One thing I want to do with the plot is add more elements to it. So I want to add 100 elements, whereas last time on Monday's lecture and the previous lecture, we only had, I think, 13, something like that. So it was kind of a sharp plot. This time we'd like to add a little bit more. The way that you will typically see that written in your future homeworks will be something like plot f of x for well, maybe from x equals -3 to x equals +3 in 100 steps. right? So we want 100 increments that go from -3 to +3. Because we're going to need it later, I'm going to start with the IDX column that I've said a few times is not really necessary because indexing is sort of happening behind the scenes, but it is nice to actually see those values every once in a while. And so we're going to use this as a way to get the first part of that plotting request, which is I need 100 points. And so I can use Excel's autofill feature by saying 1, 2, 3 to kind of get us started, and then clicking and holding on the bottom right and dragging down until I get 100 points. And I just watch that little counter over there on the right until it reads 100, and then I let go and it autofills all 100 points that I have on there. I'm going to make these like a lighter gray to distinguish them from the rest of the data that we have. So this is our first vector, right? This is our column vector. We're also going to need a column vector of x and then a column vector for f of x. Each of those will be what we call 100 by 1 column vectors, right? They'll have 100 elements in, well, I should say 100 rows and 1 column. And we're going to calculate those as we go. The formula I'm going to use for x, I'm going to give you the formula, but I'm not going to tell you where the numbers come from. So I'm going to let you think about how we came up with that number. Just remember we're trying to go from -3 to +3 in 100 steps. And so the first thing that I would do is say, well, I'm starting at -3, and then I need to add a little bit to that. And the little bit is the part I'm going to give you the formula, but I'm not going to tell you where the numbers came from, so that you can sit down and sort of reason out where those came from on your own. So I'm going to start with an equal sign. Remember, that's how we enter equations or functions or do math in Excel. And I'm going to say take the value that I previously had, the -3, and add to that a quantity of 6 divided by 99. And if I do that, I'll get a 2.9393 something, something, something. And then I'll grab or actually I'll hover on the bottom right of that cell and double click to get that to fill in all the way to the bottom. Right, and it'll autofill as long as there's something in the index column, it'll keep going. And as you can see, it autofilled all the way up to 100, and it landed exactly on the number 3, which is what we were trying to do. So I will copy that over here. So the functional form that I had there was take the previous cell value and add to it 6 divided by 99. So when you go down into, what is that, cell F10, that's essentially what's there, right? It's saying take F9 and add 6 divided by 99. I'm also going to grab that function over here just so that we have it here, that we can work with it a little bit more. The other thing that we're going to do is introduce how to use variables inside of Excel. We're already kind of using it here when we say take F9 and add something to it, and then we drag it down, it turns into F10 and add something to it. But more often we would like to define sort of single values for a particular parameter. The word for that is a scalar, right? The complexity kind of builds up from scalar is one element, a vector is a certain number of rows in one column or a certain number of columns in one row, and then a matrix is a more general two-dimensional structure. A scalar, like the parameters we need here, is just one number. And the two values that we're interested in right now creating functions for, the first is the sigma that's sitting here. So remember, this is a standard deviation of the normal distribution, and we're just going to call that sigma. The other one is the mu that sits inside of here. This is the mean of whatever your distribution is, and we're also going to call that by its Greek name, which is mu. So we're going to have a variable sigma and a variable mu. Because the completed sheet exists for me, I can't name these sigma and mu because I've named them sigma and mu over there. So I'm going to name them as my sigma and my mu. You can name them whatever you want, but that's what I'm going to end up calling them. So let's clear that off and create an area where we can do this. So I'm going to have mu is here and sigma is here. And the first thing you might say is, yeah, but didn't you just say that you were going to call them my mu and my sigma, and now you're calling them mu and sigma? I am, but we'll get to that in a moment. what we have done here is nothing more than a comment to ourselves that says this thing that's in the cell next to me, in my mind, I should interpret that as a mu. It's not going to change the way that Excel sees anything. Just to get us started, we're going to put a mu initially as 0 and a sigma as 1. And now we're going to learn in Excel, how do I refer to those and keep them from moving around? Let's focus on just this first part for a moment. So just this first chunk here, before we go any further. What if I wanted to just write that particular element for f of x, right? We'll do the second half in a moment here. What I would end up doing is saying something like 1 divided by sigma, and whatever sigma is, I would click on, so here it's f4, and then times the square root of 2 times pi. Don't forget the extra set of parentheses on pi, because otherwise you won't get pi, you'll get some kind of an error. And if I hit enter on there, I'm just going to get this 39894, which again, it's just that first chunk, because that's all I want to focus on right now. If I wanted to drag that down, right, and say, okay, Excel, fill in that formula as we go, we only need to drag a few of them down, right, before weird things start happening. We see a divide by 0, eventually we get a value. The reason for that is because Excel is updating that reference as you're dragging it down. Each time the cell or the function moves down by 1 cell, it's also taking that reference of sigma and moving it down by 1 cell. So if you double click on the original one, that one's lined up correctly, right? This sigma is highlighted. If you double click on the next entry down, the reference has gone down by 1, which is not what we want. We want a way to say, always look at F4 in order to do that. This is, in Excel, it's called locking a cell reference. And there's 2 ways to do it. The first way to do it is add $signs. There's a couple of different ways to add $signs. On at least Windows, you can accomplish this with F4. If you're on a Mac, you might have to fiddle around. You might have to hold like command and F4 or function and F4 or something like that. But if I double click on this and I see this little the F4 that's on here, what I'm after is putting a $sign in front of each one of those. If I put a $sign in front of each one of those, the F and the 4, and then drag that down, I have now generated a fixed reference where if I look at each of these functions underneath the original one, they're all referring to the same sigma. It's just a coincidence that my sigma value happens to be in cell F4, and the button to lock the reference is the keyboard button F4. It's not, it's entirely an accident. In fact, why don't we just move those so that you don't think that they're related? So now it's F6, right, instead of F4. If I'm sitting here on this cell and I start hitting F4 on my keyboard, you'll see it cycles through various ways to lock a cell reference. Most of the time we just want the double $sign, which says just always keep it at that particular cell. That's one way to do it. The other way to do it is to rename the cell itself. So when you're looking at a cell like sigma, what you see up here in the top right is the actual cell, right? It's saying you are in F6. This can be changed, right? You can put a name here to call that, any variable name that you want within reason. There are a couple of limitations for things that you're not allowed to call cells, or not allowed to call cells. For example, you can't call a cell the letter R, the capital letter R, because that's reserved inside of Excel to mean rows. So you can't call it capital R. But you can definitely call it mu or sigma or something like that, which is exactly what we're after. Whenever I use my pen, it changes that formatting, so I'll leave that back. So the second way to lock a cell reference is to rename the cell. right? You can call it something that you want. So this sigma, remember earlier I said I can't use sigma. For your own worksheet, you can probably type sigma in there and it'll work just fine. I happen to have used sigma already on the completed sheet, so I can't reuse that variable name. So this is why I said earlier I'm going to call it my sigma rather than just sigma. And now when I write that function down here, instead of saying f6, which when the functions get a little bit bigger, it can be harder to kind of read them and figure out what's what because there's a bunch of cell references in there. Instead of f6, you can say, I want to use my sigma times this square root. And that's a locked cell reference. It will not move. And now your function is a little bit easier to read, right? When I come down here and I double click on it, I can see that what I'm doing is taking 1 over my sigma times square root of 2 pi, rather than trying to do that extra effort of 1 over f6. Okay, well, what's f6? f6 is sigma. So it helps with the readability of your code. And that's one of the big strengths of MATLAB, is it has ways to declare variables like that. In fact, the only way to declare variables is through names like that, which hopefully you'll make descriptive so that you can understand your math afterwards. So what I'm going to do is I'm going to pause here for a minute, and I'm going to let you keep working. And what you need to do next is add the other element of this function. So we already had the 1 over sigma 2, sigma times square root of 2 pi. Take about 4 minutes and see how far you can get adding the exponential side, right? So you'll have to reference the mu. You can either rename it or use a locked cell reference in order to complete the rest of that function and fill it in through the rest of the empty spaces that we've got there. And then if you can, keep going and create a plot with it as well. So I'm going to wait just a second here. I'm going to turn my stuff off so that you've got a couple of minutes to work. And then I will pick this back up at about 3:21. We'll keep going. about 321, so I'll just fill in my side. The first thing I'm going to do is rename the mu cell here, which is F5. I'm going to come up here to the top left, and I'm going to say this is my mu value. And then I'm going to update this function. Let's double click on it. Actually, it's okay to update up there. I'm going to go to the end of that function, and then I'm going to say times the exponential of all of the stuff that's inside of that function. So minus 0.5 times, here you'll have to be careful with the way that you use your parentheses. You need a couple of different parentheses. The current x value is minus 3. That's just the cell that's to the left of me, minus my value of mu, and that divided by my value of sigma. And then all of that is squared and sits inside of the exponential. It looks like that is a little behind my camera, so I'll move it a little to the side like that. And then we close off the exponential. There's not really a way to rename F9 as X inside of Excel. There are a few ways that you can try that work with vectors, but honestly I'm not very comfortable with them. I don't always know what's going to happen, so I usually will not rename the thing that's got to change every step to anything else. I'll just say do it for the value that's to my left, which in this case is F9. So I'll hit enter there, and then double click on the bottom right corner, and it will auto-populate all of that all the way down. To make a plot of that, remember my, actually I don't think I used this shortcut right now, or previously. So to select lots of cells, on your keyboard, if you hit Control Shift and an arrow key, that will quickly select lots of data. So for example, I would like to select all of the values of x and all of the values of f of x. On my keyboard, I'm going to hit Control and then Shift and then the right arrow once, and it'll move over. And then I'm going to hit Control, Shift, and the down arrow, and it'll go all the way down to the bottom. So here's Control, here's Shift, and a down arrow, and it'll quickly grab all of that data that's in a continuous set right there. You don't have to use the Control Shift arrow if you don't like it. You can always just highlight with your mouse, right? You can drag it over whatever you need. They're equivalent ways of doing it, so either one is okay, but it's a nice little trick. We're going to insert a plot. Remember, we always use a scatter plot with straight lines when we're plotting a function. And as you can see, we've got our function right here, which I'm going to shrink and move off to the side a little bit so that we can see it. There we go. There's our function. We need to do a few more things. Remember, we always label the axes. So I'm going to come over here to the right-hand side of my chart. I'm going to say the plus chart element and add axes titles. For statistical distributions, they rarely have x-axes, but we can still call them f of x if we want to, right? F and f of x. Whether the grid lines show up, different folks have different preferences for grid lines. You can always click on the grid lines and delete them if you want to. I deleted them just because that's how our template was. That's over on the other page. Notice something that happens now. F of x is now linked to the values of mu and sigma. So if I change this value of mu from 0 to 1, my plot shifts. And that's pretty close to the behavior that we wanted before, right? I can do 1 or 2 or minus 1 or whatever, and the plot is shifting around as we go. Same idea with sigma, right? If I up sigma to 1.5, it kind of spreads out a little bit. If I go down to, say, 0.5, then it gets a little bit more narrow. One thing our plot is doing that the other plot wasn't doing is the axes are rescaling as we go. And if I jump back over to the other one, you'll notice when I change mu, the axis doesn't change, right? It's always minus 3 to plus 3 and 0 to 0.8. Even when sigma gets smaller and the chart actually, or the plot goes off the chart, the axes didn't change. And that's nice when things are changing a little bit. It's a little easier to spot them because at least the window in which you're looking is fixed. So the way to do that, we're going to end up doing that in MATLAB, the same in a very similar way to the way that we would in Excel. Come over to your chart, right-click anywhere on the chart and say Format Chart Area. and this little window will pop up. It's a little hard. I know you can't see underneath the window because my camera is there right now. Actually, can I move? I'll just move it over here so that you can see it. Yours is probably going to show up on the right, but since my camera is over there, I will move it over here to the left. So once you've got that format chart area up, you can click on the axes that you would like to fix. And there's this button over here that's called Axis Options. It looks like 3 bar charts. Click that, and under Axis Options are the bounds for that axis. So you can fix this to go from -3 to +3, and it'll never change. And that way we've got that sort of fixed window. And we can do the same thing for the y-axis. So we can fix that to go from 0 to 0.8 is what we had it fixed on the other one. So again, the way that I got that was click on the chart, right-click anywhere, and select Format Chart Area. And then click on the axes that you want, and underneath Axis Options, you'll have the bounds for your axis, and you can set it that way. If you're good at clicking, you can right-click directly on the axis. And I know it's off the screen here, but you can go to something called Format Axis, and it'll take you directly to that window. Let's see if you can see it on this one. There it is. If you right-click directly on the axis, you can bypass some of those steps and go directly to the Format Axis page. So we've got it fixed now. If I change my value of mu, so if I go to something like 0 or 3 or something like that, right, it has that same behavior of staying on the screen no matter where we go. And that's getting us pretty close to the behavior that we want. The next thing that we have to do is add those little spin buttons, the spin controls. This is one part that will require the developer tab that I had mentioned in, I think, like end of Monday's lecture. So right here is a developer tab. And if you don't have that right now, I would suggest that you probably just watch. And then after lecture, review the steps that I had given previously. Basically, Google Excel add developer tab so that you can get this particular functionality. Otherwise, it's okay if you just want to watch along for a few minutes here. So what we're going to do is go to the developer tab, and under insert is a form control that's a spin button. There's some other ones under there that are ActiveX controls. Honestly, I've never used them. I can't tell you what the difference is, other than they don't seem to work the same. So just use the form controls, don't use the ActiveX controls right now. And the one that you want is called a spin button. It looks like an up arrow and a down arrow. When you click on spin button, you'll get a pair of crosshairs that you can use to draw your spin button. And you can resize it as well as you go. So we're going to start with the mu controller. So this spin button is going to be our controller for mu. The way to set up these controllers, and this is very similar in MATLAB as we'll see when we get to that. If you right click on it and say Format Control, that will bring up this page. And so again, what we're doing is editing the format control so that we can see what's going on. There's a couple of different things. One is the current value. That just says what's the number of the cell that we're currently at. The minimum value that sits on here, the minimum value always has to be greater than or equal to 0. It can't go negative. The maximum value, I don't know exactly what it is. I just know it has to be greater than the minimum. I don't know if there's an upper bound. It could very well be 30,000. I'm not sure. And then the incremental change, that's what's happening. Every time you click that button, that's how much the number will change. And the incremental change always has to be an integer. So it'll only change by an integer. So you can set that to be 2, 3, 4, 5 or whatever, but you can't set it to 0.2 or 0.5 or 0.8 or something like that. And then the last part is this cell link, which is the last one. This is where the value gets set, or the value gets written. So whenever I click the button, it will update a number that is somewhere between the minimum and the maximum that gets changed by the incremental value and is stored in whatever cell we happen to have right there. So what I'm going to do is give this a cell link, I am going to click on the value or this cell that's next to it, which is, I think, J4, but you can pick whatever cell you're interested in. And I'm going to click OK. And I just want to make sure that's got the right formatting. So now as I click up and down, I can change a number somewhere between 0 and 30,000. So I've got the functionality of the controller over here, and I've got the value of mu over on the other side. If it so happens that the controller can directly give you the value that you want, if you just need to vary something by an integer greater than 0, then maybe that's all you need to do. More often, though, the value that we get out of a function has the correct behavior in the sense that it's controlled by the controller, but the range might not be right. Another time that this comes up is random number generation. So if I want a random number between 20 and 30, I might have to use a random number generator that only gives me values between 0 and 1. So I need to think of a way to say, this is what I can get from a function. I can get between 0 and 1. How do I translate it to something else, like between 20 and 30? Here I've got a controller for mu that goes from 0 up to basically any integer that I want, but I would like to be able to use that number to calculate a value of mu that's kind of between -3 and +3 or something in that range. So what I can do instead is take this value of my mu, and instead of a constant there, I can create a function here that refers over to the value that's generated by the controller. So I can say, for example, take the controller value and subtract 5 from it. If I take the controller value and subtract 5, now when the number goes down, I can, get off to the -3, -4, -5, something like that. I can't go any lower than that, but that's okay. I only needed to go to -3. And I can also go up as high as I want. So that's one way that I can modify a controller to behave in a different way. If I wanted to go in smaller increments, right? Maybe I wanted to say, take that quantity, shift it, but also go by increments of 0.1 or something like that. Now I've divided that quantity by 10, and it's shifting it by a much smaller amount. And so you kind of have to play these games of algebra. Usually there's a little bit of trial and error in there, right? To just figure out what's that relationship. The controller is giving me integers. How do I take those integers and turn them into values that I want? So for sigma, whatever sigma happens to be. Or in this case, mu, as we're working with right now. So I'm going to leave the mu to go between essentially 3 and -3, right? So it covers most of the range that I want. I can technically go out to -5, but that's okay. I've got the majority of the behavior that I want here. So let's take about another, we'll say maybe 5 minutes here, and see if you can create a sigma controller. And so what you're after is make sigma, or I should say make controller vary sigma from 0.1 up to whatever value you want. It can kind of go as high as you want in increments of 0.1. Right, so that's what I want you to work on for about the next maybe 5 minutes or so, a little bit more possibly. We'll be back at, let's say, about 3:39. That should get us pretty close to it. So it can start, it should be, the lower bound should be 0.1. The upper bound can kind of be whatever you want it to be, and then it should move in increments of 0.1. Remember, to get the controller, you need to be in developer and then go into insert and then form controls. And I'm going to give you now some time to work through that and see if you can get that controller set up to vary sigma as well. I'm going to disappear too so that you can focus. Okay, it's about 3:39 here, so I'm going to add the spin control for my Sigma controller, put it over here. I'm going to right click on it and say Format Control. I'm going to link it to the cell that's right next to it. And you may come up with different formulas that you want to use for something like this. For me, the first one that showed up was, well, I can set the minimum value to 1, and then I'm going to take whatever that value is and divide it by 10. And that'll give me a number that will get no lower than 0.1, and then it'll increment by steps of 0.1. If you've got a different formula that you wanted to use, that's probably okay, right? As long as it has the same behavior, it's probably going to be okay. That's just the first one that occurred to me. So I'll test my controller. You know, it's like when you're cooking and you just have to tap those tongs or something like that. I'm in the habit of just clicking on my controller a little bit just to make sure it's moving. And then I'm going to take my cell for Sigma and say equals M4, which is my value written by my controller, and divide that by 10. And so now as I spin my controller up or down, I can see that my chart is moving in the way that I want, and that seems to have accomplished the goal that we're after. Notice I never have to update any of the functions down here because these functions are always looking back at the Sigma. All I'm doing is now telling the Sigma, look somewhere else for your value. I can still come in here and just type a value, right? If I wanted to type this as 1, that would be okay. But now I've broken that link, right? I've deleted that function, but that's roughly the way that this is functioning, right? I'm just telling the value that's being used in the function, well, take yourself and actually look to a different cell in order to determine your value. So we're just sort of rolling the ball up the hill, right? The other way around. We're saying the actual control is set by this little spin controller over here. Everything else just follows as a result of whatever the current value of the spin controller is. The last thing that we wanted to do is work on indexing. We had briefly mentioned this before when we had first generated this gray value of index values. What that was originally written as on Monday, or the way it was originally interpreted on Monday, was there's a difference between the position of a piece of data inside of a data structure and the value of that data. So for example, this -3 has obviously a value of -3, but it has an index of 1 because it's in the first position of x. Similarly, this 0.0027, that's its value, but its position within f of x is position 1. Similarly, you know, if you go down here to the 7th one, the 7th value of x is about -2.6, and the 7th value of x, f of x, is 0.0037. In Excel, indexing is kind of, it's used for some special cases. I wouldn't even say special cases. It's used for certain things in Excel. It's used a lot in MATLAB, which is why we're introducing it here, even though there could be other ways to accomplish exactly the same thing that we're trying to do here. And so the way that the indexing works, I'm going to shift my plot over to the side because we don't need it right now. The first thing that I want to do is say, which value do I want? So I'm going to write that as IDX. Notice I'm not actually defining anything here, right? That's just a comment to myself. So it doesn't matter that this index is the same as this index, the grayed out one over here. Those are just comments, right, to remind me of what's being entered in these cells. Let's say, for example, that I would like the third element of x. So the index that I want there is 3. It means find the third element inside of x. The function that we use to extract values by indexing inside of Excel, so to extract indexed values, that function looks like this. You say equals index, that's the function name. Then you provide the array that you're interested in, as well as the actual index number that you would like to extract. So the array is whatever you want, right? In our case, it's going to be x, or later f of x. And IDX there is, tell me what the actual number is, the index of the thing that you would like there. So we want to get x's first. So underneath it, I'll say x is equal to something. And now I'm going to say equals index. And Excel has auto-populated the most likely things that we want to use here with index. And the first one is exactly what I had written over there on the left, just in sort of Excel jargon. The first thing we want to give it is the array. That's going to be our vector x. And then the next thing we want to give it is our row number, right? And that's saying, well, where do I go inside of x to extract the value? There's an optional one next to it called column number. That would be used if you had, for example, a row vector. So if your numbers weren't in a column, but they were across a row, then you'd be referring to rows. If you had a matrix which has both rows and columns, then you have to say, okay, go down this certain way row and go over this certain way column, and you would use indexing that way. We just want to index into x right now. So the array that I want is x. So I'm going to click and drag over the entire thing of x. I want to be able to go all the way down. And the value that I would like to extract, the index, is what's set in the cell above it, right, in I9. Right now I would like the third value. So sure enough, the third value, 2.87, that's 2.87, right? You can play around with it a little bit just to make sure that as you change the index, the returned value is the correct one. The dogs are a little excited, so hopefully they're not too loud. And you can go higher or lower. Some weird things happen as you go higher and lower. So if you go up to 99, everything is okay, right? It's the last value. If you go up to 100, it's also okay because that's the 3 value. If you go to 101, you get an error. The reason for that is because there is no 101st element of your vector x, right? There's only 100 elements in there. Similarly, you get weird problems if you give it a negative number, right? In this case, there is no such thing as a negative index number. They all start at 1, right? You start counting at the first one, otherwise there's nothing there. Excel gives weird numbers when you give it a 0 index. It actually defaults to give me the entire vector, which isn't really used that much. So really it only needs to go from 1 to the length of the vector. Anything more than that, and it's not particularly meaningful. And in fact, most of the time it'll just give you an error and say there is no such value, right? I can't get the -2 index or the 101st element because they don't exist. We can do the same thing with f of x. The only thing that will change is we'll write equals index, and now the array is different, right? We want to look at the array for f of x, the column vector for f of x, instead of just x. So this time I'll do the Control-Shift-Arrow key. So I'll click on the first one and then hit Control-Shift and down arrow, and that will get all of the f of x values. And then the row number that I want is that same index that we saw before, which is here. And so now I'm getting both the x value here and the f of x value here, right? But now they're popping out over here. And so the way that I visualize doing something like this, let me move my cursor so that it doesn't mess up, is we've got like this sliding window, right? You can imagine a sliding window that looks at a particular row of our data that we have over here. So when IDX is 1, it's saying take a look at this first row. And then if IDX is 4, that means take a look at the 4th row. If IDX is 8, then it would come down here and have this sort of window that's looking at the 8th row. We happen to split it up to say sometimes I want x and sometimes I want f of x, but it's a similar functionality that's happening in both of those. It's just a visualization tool. It's the way that I like to think of the way that this thing is working. But as you get more and more familiar with indexing, you'll sort of build up your own mental picture of what's going on. I like to think of it as, this box that you can see right here that's just sort of sliding up and down inside of that vector. If we wanted to add a controller for that, we can do pretty much the same thing that we did before, right? This is ultimately going to be our marker controller, so I'm going to label it as a marker controller. So if I go up into developer and insert another form control up here, I know it's going to need to affect that index, so I'm going to say format control. I know it shouldn't go any lower than 1, and it shouldn't go any higher than 100. But changing in incremental changes is okay. And my cell link, I can actually just link that directly now to the index, right? I don't need that extra step because the controller is giving me exactly what I want, which is an integer between 1 and 100. So it's not necessary to give a unique position to the controller's cell link. It can be whatever you want. If it happens to be exactly what you need, then you can put it over there, and it'll work just fine the way that it is right here. So what we're going to come back to tomorrow is, or not tomorrow, on Friday, is that last step of how do I add this to my plot as two elements. And they're actually very closely related. So if you look over on the completed one that we have over here, when I change the marker, it moves the red dot and it moves the line. That final element of updating the numbers up here is sort of unrelated, but well, actually it is somewhat related. So we'll introduce that as well when we come back on Friday. But for now, I'm going to stop here because we're coming up on 3:50, and I always want to make sure that I end pretty much on time so that you've got plenty of time to get to whatever your next lecture happens to be. Again, I will post this particular document. The completed code, you're welcome to keep working on it because we'll go through it fairly quickly on Friday. The completed code is over here. I've just turned the text white. So if you highlight all of these and change the text back to a color, like a black or something, you'll be able to see the solution that sits under there if you want to. But I've left it blank in case you want to try to work it out for yourself without having those solutions in front of you. And then we'll generate those solutions on Friday's class. So that's it. I'm going to wrap up class today. Thanks for coming out. Stay safe, stay healthy, and we will see you all on Friday. I will stick around over in the Canvas chat too if you've got any other questions. But otherwise, I'm going to wrap it up on Twitch. Have a good one all. We'll see you soon.